I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. In this video, we are going to discuss very important questions based on limits. All these questions have been taken from past test papers, and I hope their solution will help you understand the topic. Normally in calculus, in the very first unit, limits is a major part. I shouldn't say it is all the part, but it does have 50% weightage. We'll consider limits of the functions at any point in between where there could be a 0 by 0 situation, which is, we call it indeterminate. We'll consider limits at infinitely large values in another video. So here are 6 questions for you. You need to find limit of these functions. To help you factor, we have difference of cubes and sum of cube formulae. Some students may not remember, and these may be required in question number 2 and maybe in question number 5 and 6. We are going to use 3 different strategies to find limits. I should say 4. I'd like you to actually pause the video, answer these questions, and then look into these strategies. In case you want to learn from me, you can always send an email on the address given. Now, let's begin with the solution of these questions.
After attending university. The winner of this year's Certificate of Achievement Schulich Leader Award is anil.anilkhandelwal.
Great. Our student Akshit gets highest marks and the most prestigious Schulich Leader Award. You can be there. Join our classes and excel. Question number 1 is straightforward. We are given limit x approaches 2. We need to find this limit for the function x squared minus 2 over x plus 2. Now if I substitute 2 here, what do we get? We get 2 squared minus 2 over 2 plus 2. Now 2 squared minus 2 is 4 minus 2. And 2 plus 2 is 4. So we do get 2 over 4, which can be simplified and written as half. So the idea here is, when you substitute, you get an answer, right? So we did this by the method of substitution. Is that clear to you? Simple as that. So whenever you have to find limits, it's a good idea to directly substitute the value. Since limit really means x approaches 2. Well, if you can be there, why not be there? That's the concept of substitution. If you cannot be there, then you have to be as close as possible. That is the meaning of approaching. And when you are approaching, you are approached from both the sides and look for same values. Perfect. So we got the first answer, which is straightforward. By substitution, it is half. Now let's take up the second question, which is x cubed minus 8 over x squared minus 4, and x approaches 2. Now in this case, if I substitute 2 for x, I get 2 cubed minus 8 over 2 squared minus 4. Now that is 8 minus 8 over 4 over 4, and that is a form which is 0 over 0. So when you get this form, we call them as indeterminate. So this value, 0 over 0, is actually not defined. However, it tells you one thing, and that is we have a common factor. Do you see that? And clearly, the common factor is when x approaches 2, the value is 0. That means the common factor is x minus 2. So now we have a couple of strategies to work with. We could factor both numerator and denominator. Perfect. So one of the strategies is to factor. which we are going to apply now. Correct? And I've given you this formula of a cube minus b cube, right? It helps you to factor, clear. So let's do this factoring and get our result. So we have to find the limit when x approaches 2 for x cube. I'm writing 8 as 2 cube, right? And then we have x squared, and I'm writing 4 as 2 squared. So clearly, as you can see, we have difference of cubes and difference of squares. I can now apply this formula and factor. Clear? So let's do that. So we get this as limit x approaches 2, and the numerator, we have x minus 2 times x squared plus 2 times x plus 2 squared, which is 4, divided by x plus 2 times x minus 2. And as you can see, x minus 2 cancels, and therefore we have an expression in which now if we substitute x equals to 2, we may not get 0 over 0, right? So substituting 2 in x squared plus 2x plus 4 over x plus 2 may give us the result. Perfect. Let's try it out. So when you plug in 2 here, you get 4 plus 4 divided by 2 plus 4, right? 2 plus 4, no, I think it was x plus 2, 2 plus 2, right? So the factor which remains is x plus 2, so x 2 plus 2, perfect. And that gives you the answer, 12 over 4, or just 3. And therefore, the limit of this is 3. Perfect. Very simple. Second question. We just moved across very fast. I hope it is absolutely clear. In case I am going fast, you can always slow down the speed and then look into the solution. But the idea here is, how do we apply difference of squares and difference of cubes to simplify or factorize and get the answer? Question number 3. Here is quadratic expressions in both numerator and denominator. You will test, then when you substitute 3 here, then you do get 0 over 0. And therefore, we need to do something about it. We cannot get the answer by direct substitution, and strategy is to factor. So let's factor the trinomials and get the answer. So we have to find the limit when x approaches 3, the numerator being x squared minus 2x minus 3, denominator is x squared minus 4x plus 3. So when you factor the numerator, what do you get? Keep writing limit approaching 3 with every expression, okay? So limit approaching, for x approaching 3, the numerator is minus 3 and minus 2. That means minus 3 times 1. So x minus 3 times x plus 1 will give us the numerator, and the denominator will be x minus 3 times x minus 1. Perfect. Right? You agree with me? And now x minus 3 cancel. So it simplifies to limit x approaches 3, and we are left with x plus 1 over x minus 1. Substituting 3 now gives us 3 plus 1 over 3 minus 1, or 4 over 2, which is 2. So this limit is 2. Perfect. So do you see? When we get 0 over 0, it clearly indicates a common factor, and the common factor relates to the limit approaching value, which is 2 in this case. And therefore, as you can see, the factor, 3 in this case, so the factor which cancels is x minus 3. Make sense? Perfect? Great. So, let's go to the next one. Here again, if I substitute the value 0, we have to find limit x approaches 0 for square root of 5 plus x minus square root of 5 over x. Substituting 0 will mean 5 plus 0 minus square root of 5 over 0, which is square root of 5 minus square root of 5 over 0, or 0 over 0. Now in this particular case, wherever you find radicals, it is a good idea to rationalize. So that is the third strategy. First one being substitution, direct substitution. Second being factorization. And third is rationalize. So let me do it with rationalization. So we have limit x approaches 0, square root of 5 plus x minus square root of 5 over x. Now, rationalization really means multiply by the conjugate and also divide by the same term. It means multiplying by 1, right? So let's do it. So we have conjugate of minus is plus, and therefore we are going to multiply and divide by square root of 5 plus x plus square root of 5. And then we know what we get. Well, in the numerator, it is difference of squares, correct? So we get square of square root in this case will be 5 plus x, and here it will be minus 5. And in the denominator, we get x times, within brackets, square root of x plus 5 plus square root of 5. Now let's simplify the numerator. We can write this as limit x approaches 0. 5 minus x becomes 0. So we have x in the numerator divided by x times, within brackets, square root of x plus 5 minus square root of 5. X and x cancel, and so we can write this as limit x approaches 0, 1 over square root of x plus 5 plus square root of 5. Now we can substitute 0 for x and get the result. So we get 1 over square root of 0 plus 5 plus square root of 5. Now that gives you 1 over square root 5 plus square root 5, which indeed is 1 over 2 square root 5, correct? Now, it is a common practice not to write square root 5 in the denominator, so I'll request you not to stop at this stage. If you're really trying to get 100% marks, this is very important. Rationalize the denominator. So we need to multiply and divide by square root 5. Once you do that, as you know, you get square root 5 over 2 times square root 5 square, which is 25. You could have written directly. The idea was not to write the denominator with radical sign. So this is 5 times 2 is 10, correct? So basically, you do get this limit, and it is square root 5 over 10. 2 square root 5. You get the idea. So I think the concept here is absolutely clear, and we have seen how rationalization works. Perfect. And earlier, we had seen how factoring techniques work, correct? Now let's continue and take up the next question, and this time slightly more complicated. We have the question as limit x approaches 4, x to the power of 3 over 2 minus 8 divided by x minus 4. Now in this particular case, if I substitute 4 here, then we get 4 to the power of 3 by 2 minus 8 over 4 minus 4. Denominator clearly is 0. Anybody can see that. But in the numerator, sometimes it becomes difficult to work it out. When I say 4 to the power of 3 by 2, it really means square root of 4, that is half, and then cube it, correct? Minus 8, and that indeed, you know, is 8, and 8 minus 8 is 0. So we do get indeterminate form, which is 0 over 0. So at this stage, you could actually factor and then do the question, or you could change the variable. So here we will adopt one of the two strategies. One, we could factor. The other is change of variable. Change of variable is a very strong technique which I'll recommend students to master. Initially, it seems to be difficult. However, once you get the hang of it, you will love to use it. Let me show you how both these techniques work one by one. Okay, let's first factor this. So we have this expression. So let me only show you the factoring part, and then we can find the limit, right? So let's work out the limit also. We have x approaches 4. We know 4 is giving us 0 in the numerator. Now look here. x to the power of 3 by 2. We could write this as square root of x, right? To the power of 3 minus 8, which is 2 cube, divided by square root of x square minus 2 square. Does that make sense to you? See how we have rewritten the equation. Now we can apply difference of cubes and difference of squares to answer this question. Perfect. So this could be written as square root of x minus 2 times square root of x square plus 2 times square root of x plus 2 square, which is 4, divided by square root of x minus 2 times square root of x plus 2. Clear? You could now cancel the factor which made 0 by 0, this indeterminate form. You get the idea. Don't forget to write limit. So you should always write limit as we move along. So we now get the limit x approaches 4. Since one of the factors cancel, we have square root of x squared plus 2 square root x plus 4, and here we have square root of x plus 2. Substituting 4 is not a problem now. Substituting 4 is not a problem now. So we can substitute 4 here plus 2 square root 4 plus 4 over square root of 4 plus 2. Now that gives you in the numerator 4 plus 4 plus 4, right? Which is 12 divided by 2 plus 2, which is 4, and that is 3. So we get this limit as equal to 3. So you see how we could actually simplify, factor, and then get the limit for this particular case. Now let's look into the alternate method of solving the same question, and this time we are going to use change of variable. So as I was discussing, we have the term x 3 by 2, right? So which is square root of x whole cube. It is a good idea to substitute square root x as some other variable. So let square root of x be equal to some variable p. In that case, what is square root cube? It is p cube, correct? And also you have to see what happens to the limit x approaches 4. Now you can check that if x approaches 4, in that case square root x will approach what value? Which will be square root of 4, and this approaches 2. Now we know that p is going to approach 2, correct? Since square root of x is p. So we can rewrite the expression. So let's rewrite the expression. We have limit x approaches 4, x to the power of 3 by 2 minus 8 over x minus 4. So when I change it with the variable p, I get limit p approaches 2, right? And we have p cube minus 8 over, we have p square minus 4. Since x will be square of p, right? So that will give you that x will be p square. So we are going to make these two substitution, right? So x is p square and square root of x is p. So this is square root of x, which is p. Now we can apply difference of squares and difference of cube. So in the numerator, we have p cube minus 2 cube, as we had seen earlier, and here we have p square minus 2 square. We can always factor this and get the result, correct? So let me rewrite this with limits. So we have limit p approaching 2, we have p cube minus 2 cube divided by p square minus 2 square. So that is equivalent to limit p approaches 2. See how the limit also changed. And let's factor this. P minus 2 times p square plus 2p plus 4 divided by p minus 2 times p plus 2. You can now cancel p minus 2 and p minus 2, giving you limit p approaches 2, p square plus 2p plus 4 over p plus 2. Now if I substitute 2 here, I get 2 square plus 2 times 2 plus 4 over 2 plus 2, correct? And that gives you 4 plus 4 plus 4 over 2 plus 2, which is 4. So we get 12 over 4, which is 3. And we get the same answer which you got last time. Is that clear to you? Let's try to understand this method of change of variable. Extremely powerful technique. I hope this is absolutely clear. Now, can you pause the video, answer this question and use this technique of change of variable? Now this is difficult, or I should say a challenge. Test question. I'd like you to really pause the video, try it out, and suggest what kind of change of variable can you use in this particular case. So the question given to us is limit x approaches 1, and we have square root of x minus 1 over cube root of x minus 1. Now, some of you may think like this. We are given limit x approaches 1, in the numerator x is to the power of half, and in the denominator x is to the power of 1/3. Now how can I change the variable to really solve this question? So look here, if I use the substitution, I should say change of variable, as x to the power of 1 over 6 equals to p. In that case, what happens to x to the power of 1 over 6 cube? It will be p cube, correct? And that indeed is x to the power of 3 over 6, right? Which is p cube. Now 3 over 6 is x to the power of half, right? Does it make sense to you? So x to the power of half, I could write as p cube. Is that clear to you? Now also look at x to the power of 1 over 6 whole square. So in that case, it will become p square. Now this is x to the power of 2 over 6, which is p square, and that is x to the power of 1/3 cube root, which is p square. So you see, x cube root can be written as p square. Perfect. Now square root of x in this case, whereas x approaches 1, is what? Is also 1. So p also approaches 1. Can you now substitute the variables and then answer? So I have already given you change of variable concept, correct? Which is, we want to change this with x to the power of 1 over 6 equals to p. Perfect. In that case, the square root is p cube and the cube root is p squared. Perfect. Okay, some of you must have got it by now. Let's now continue with this change of variable. So the concept is change of variable. This question is otherwise very difficult, okay? So change of variable we defined as x to the power of 1 over 6 equals to p. Now clearly, if I cube it, then we get what? We get x to the power of 3 over 6 will be p cube, and that implies that x to the power of 3 over cube is square root, right? Is p cube, correct? And if I do x to the power of 2 by 6, that will be p square, which means that the cube root is p square. Perfect? And of course, we know that sixth root of 1, if x is 1, is 1, right? So, when x approaches 1, p approaches 1, right? So, let me rewrite this expression. I could write this expression as limit x approaches 1 will now become p approaches 1. Square root of x, as we did just now, is p cube. So I'm going to write this as p cube minus 1, and denominator is p square minus 1. This we have done so many times in this video. So you must have appreciated how one particular thing can be written in so many different ways, and then we could have a challenge question. You get the idea, right? So just factor this out using difference of cubes and difference of squares. Cancel the common factors and get your solution. You get the idea, right? So you get limit p approaches 1, and in the numerator we have p square plus p plus 1, denominator is p plus 1, correct? Substituting 1, because now you can do that, will give you 1 plus 1 plus 1 over 1 plus 1, which is 3 by 2. Or that's the final answer, correct? So let me rewrite the answer here, which is 3 by 2. Does it make sense to you? So that is how we could actually find the limit of the questions given to us. So we went through the whole exercise, solving each and every problem. We saw how this formula, a cube minus b cube, is very important to understand and solve these problems. Also, in the last case, it is very important to understand change of variable technique. So we did use all the techniques known to us, which are 1. To factor, to rationalize, to change variable, and then answer these questions. There are other techniques like L'Hopital's rule, which we'll take up in another video. I hope all this makes sense. Feel free to write your comments, share your views, and if you like and subscribe to my videos, that will be great. Thanks for your time and all the best.